Hey guys, in this video we're going over chapter 6, the last section, solving radicals. So in the last few sections we've been talking about what radicals look like graphically, what their solutions. Hey guys, this is our last section from chapter 6, solving equations that include radicals. In the last few sections we talked about what radicals look like graphically, and then we also talked about how to simplify radicals and perform some basic operations with radicals. So this last section, you're going to see equations, and we're going to solve and try to figure out what's the value of x within the radical equation. We do have 3 steps that we try to complete as we're solving radical equations. Step number 1, we want to make sure that the radical is isolated. Okay, it's kind of like an absolute value. You want to isolate it before you try to get rid of the radical. Step number 2, to get rid of it, you're going to raise both sides to the same power. So if it's a square root, you will square both sides. If it is a cube root, you will cube both sides, and so on. And then step number 3, solve the resulting polynomial equation. So once we do that last step, we're going to get rid of the radical symbol, and then we just need to keep solving like a traditional algebraic equation. Alright, so let's go ahead and get into this. In this video, we're going to go over questions 1 through 6 in your packet from this last section. So number 1, first check is the square root isolated? So looking at it, you can see that the square root of x is by itself on the left hand side, so it is isolated. So now we can move on to step 2. So we want to raise both sides to the same power, and since our index is a 2, with this being a square root, I'm going to raise both sides to the second power. So square root of x equals 9. I am raising both sides to the second power. I'm just squaring both sides. Okay, the purpose of doing that is going to get rid of our radical symbol. Okay, those are inverse operations, and we're left with an x. And then on the other side we have 9 squared, which is 81. So the square root of what number is equal to 9? Well, the square root of 81, right? So this here is the answer we're looking for. I did check that solution mentally. I just plugged it in to make sure. Yes, the square root of 81 is 9. So we're good. This is a real solution, not an extraneous. Let's take a look at number 2. So number 2 is the radical isolated. Is it by itself on the left-hand side? The answer is yes. Now there is a minus 3, but that's underneath or inside of the radical. So it's not separate from it, okay? It is isolated on the left-hand side. We are ready to raise both sides to the same power. So my index is a 2 again, so I'm going to have to square both sides. Okay, I'm squaring the left-hand side, squaring the right-hand side. Now notice every time that I do square the side, I like to put it in parentheses just to emphasize I'm squaring everything. So common mistake here is some students on the right hand side wouldn't square a negative 8, they would square positive 8, and that's going to give you a different answer. Make sure that you are squaring that whole side once you have everything isolated. Okay? Alright, so we're squaring both sides. Remember, the purpose of doing that is to get rid of that radical symbol, so we're left with just an x minus 3 when I square the left hand side. On the right hand side, negative 8 times negative 8 is positive 64. Okay, let's add 3, and we get 67. Alright, so now let's just plug this one back in to make sure that everything's looking good. So plugging it back in, I have the square root of 67 minus 3, which is 64, and if I do square root that number, I get 8. But the other side says negative 8. Okay, so this 67, that's what I found x to be, but we just see that that's an extraneous solution. It doesn't work. So I'm going to put that down. This is an extraneous solution. Okay, and really there's no solution to this problem. Okay, 67 was extraneous. There's not a real solution to number 2, because looking at the problem, some of you guys probably caught that at the very beginning, but the square root of something can never be negative unless we're talking imaginaries. And right now with an equation, we're not talking imaginary. So this is a no solution problem. All right, let's move on. Number 3. So the first thing that we ask ourselves, is the square root isolated, or is the radical isolated? In this case, it's not, because we have this -8. So we need to get rid of that before we can raise both sides. So I'm going to add 8 to start. And now I have the square root of x plus 13 is equal to 6. Now it's isolated. It's by itself. Go ahead and raise both sides. My index is just a 2 again, so I'm still squaring. I'm going to go ahead and raise both sides to the power of 2. That's going to get rid of my radical sign, and I'm left with just what's underneath. So x plus 13 is equal to, and then 6 squared is 36. Okay, go ahead and solve this polynomial expression, or polynomial equation. Subtract 13 from both sides, and we get x is equal to 23. All right, now before I circle this, I'm going to check it just to make sure it's not an extraneous solution. If I plug 23 in, 23 plus 13 is 36. Square root of 36 is 6. 6 minus 8 is -2. So we are good. This is a real solution here. All right, number 4. So number 4, the radical is not isolated. Let's take care of that first. Subtract the 9. We're left with a negative square root of x plus 12. On the other side, we now have -6. All right, now I see a negative in front of my radical. That's just a multiplier. So let's get rid of that by dividing by that by a -1 to get rid of that negative sign. So divide both sides by -1, and we have x plus 12, and the radical is equal to 6. All right, the radical is now isolated. Let's square both sides. That gets rid of my radical symbol. X plus 12 is equal to 36. Subtract 12. X is equal to 24. Confirm it. 24 plus 12 is 36. Square root of 36 is 6. 9 minus 6 is 3. All right. Let's move over to the next page. We got 2 more. And looking at these 2, hopefully you guys can see that the index isn't a 2 anymore. So let's make sure we understand how to do 5 and 6. So for number 3, we start off the problem the same way. Is the is the radical isolated? Is it by itself? And the answer is yes again. So we can go ahead and raise both sides to the power we need in order to get rid of the radical. Now since this is a cube root, to get rid of the radical, we're going to have to cube both sides. So I'm going to raise it to the 3rd power. And remember, when you raise it to that, raise that side to that power, think of it as in parentheses so that you're taking everything to that power. All right, so when I do the cube root cubed of x, that's just x. And -5 cubed is 125. And it is negative because 3 negatives would be negative. So -125 is what I'm getting for x. I guess before I circle that answer, I should check it. The cube root of -125, does that give you -5? The answer is yes. You can check these things on a calculator if you like to, but it does work. Okay, number 6. Our radical is not by itself. Let's take care of that. I'm going to subtract 3. And I have the 4th root of x minus 2 is equal to 3. This is the 4th root. Okay, to get rid of that 4th root, I'm going to have to raise it to the power of 4. That'll get rid of my 4th root. So I have x minus 2 is equal to 3 to the 4th. Should be 81. Let's add 2 to both sides. 81 plus 2 is 83. So we're getting x is equal to 83. Now let's just check this plug it in. 83 minus 2 is 81. Fourth root of 81 is 3. 3 plus 3 is 6. So this is a real solution. All right. So we just went over the first half of the notes from this section. In the next video, I will go over the next set. Thanks for watching.